We're looking at the clocked SR latch. And the first thing that you should notice, the way the simulation is running, is our Q and QN are actually errors. And it's because everything has just booted up. And uh, and we don't really know what Q or Q naught can be. Uh, Unless we threw in some pull up or pull down resistors, we'd be able to set them. But as it turns out, it doesn't really matter for the sake of our simulation. The moment we write something, it will write or set or reset. It will do what we need it to do. So uh, the way this works is, say I wanted to write a 1 to Q. So I'm going to set my set input to 1, and nothing happens yet, right? Nothing happens because this is a positive level gated uh, latch, right? We need to see a 1 on the clock, and then something can happen. So if I set my clock to 1, there we go. I'm able to write this gate. And as long as this clock is a 1, I can change the output. As long as the clock is a 1. The moment it goes back down to 0, S and R can be anything, and Q won't change. Only when Q, or only when C is a 1 can Q, and consequently Q not be changed. And so we see we give the clock a positive pulse, and Q writes, right? We write a 0 to Q in this case. So this is necessary because we know that it takes time for digital signals to change. And so if we were trying to go from a 0 1 to a 1 0, right, we wanted to go from a write state to a set, or a reset state to a set state. These signals need time to change, and suppose we were in this state, and let's say that just for a fraction of a second, fraction of a fraction of a fraction of a second, set arrives at 1 before reset arrives at 0. Now, we know that this is our forbidden state for our SR latch, and that can cause some problems. And so the clock helps us out here, because if the clock is a 0, as we're changing our signals, it will make it so Q cannot be changed. It will only be changed when C is a 1.